Hello, everyone. So I'm Sasanka Gallage. I'm doing the study on leveraging Scan-to-BIM for adaptive reuse, and I'm a PhD researcher at the University of Adelaide, and my supervisors are Associated Professor Scott Hawken and Ruidong Chang. So this is the outline of my presentation today. So I'll be starting with a small background of me, leading on to the starting point of this research and what sort of a process I've been going on currently. Yeah. So a little bit about me. So I'm a quantity surveying graduate, and since 2018, I've been working in industry as well as academia. And I'm a certified quantity surveyor in the international chapter of Australian Institute of Chartered Quantity Surveyors. And I recently started my PhD work at the University of Adelaide. So it's only been about 3 months so far. So if I think about the starting point of my research, so I started with the analytics topic 6, where I focused on the barriers for architects or industry adapting new technology and what sort of implications they would have on the workflows. So when looking into the topic, uh, we they highlighted the four main areas: accessibility, training, cost of use, as well as communication as way of addressing barriers. So this was the starting point of my preliminary literature review. So when looking into the literature, I was able to identify that there are many technologies available currently which can address these four main themes of barriers. So when looking into the new technology, they can be classified into nine like broad classifications. And when further looking into these classifications, it was interestingly found that they are kind of interrelated, and they feed data from one system to the other to like uh, get better, efficient outputs. And out of these different groups, the reality capture technology kind of piqued interest because it has the capability of feeding information to all other systems to have better outputs. So with that in mind, I went into the reality cap, like went into further analysis of reality capture. So the reality capture is basically uh, like acquiring data about the current state of spaces and construction assets and converting them into 3D built assets. So the common methods that are currently being used are the terrestrial laser scanning, the mobile mapping systems, and photogrammetry and aerial image sensing. So the data that is like captured from all these methods are like converted into, or they are mainly being exported as point clouds, mesh surfaces, or digital elevation models or auto imagery. So, however, once we process this data, we can use the processed data in an interoperable manner to feed into other technologies such as digital twins, uh, construction project planning, industrial fabrication, and other techniques. So, to convert this data into interoperable system, the Scan-to-BIM was identified as a major uh, enabler. So with that Scan-to-BIM, we can feed accurate geometric baselines for digital twins and provide labeled elements for construction planning and field augmentation. So we have a foreseeable potential in Scan-to-BIM. So with that, when it comes to Scan-to-BIM, it's not something brand new. It's already existing, and there are like uh, a significant amount of literature out there. So a Scan-to-BIM is basically a workflow that translates the real-world conditions captured by laser scanning into BIM. So when we look at the current literature, so I identified that Scan-to-BIM is being used in buildings as well as infrastructure for mainly creating these as-built models for verification of the as-planned building and for structural health monitoring and certain simulations. And when we are looking into the buildings, there was another major branch focusing on built heritage, how to capture the built heritage, and how to like disseminate the heritage data or conservation data onto other platforms. So, but when we look at the scan-to-BIM process, currently the majority of the processes are manual, and you have to plan your surveys, and you have to use the laser scanning equipment, and you have to take the equipment from one place to the other. But if you are using a mobile scanner, then again you have to have the large backpack and certain arrangement, and you have to walk around the building to capture it. Then the acquisition is not done yet, so you have to process that data further in, like there will be pre-processing involved, and after that you have to reduce the noise in the captured data, and further you have to take it down to modeling, and the modeling part is mainly done in manual process. So you take the scan to BIM data, and you take it as a baseline to develop the model. But however, with the development of these deep learning algorithms, so there have been certain developments in this field where they can assist or kind of semi-automate the processes. So point clean net can reduce the amount of noise in the scanned outputs, and with the point net algorithms, we can try to identify different elements so that it can be used in the BIM model more efficiently. So there have been some developments in the scan to BIM area as well. And when looking into the applications, I saw that even though there are scan to BIM studies on existing buildings as well as built heritage, uh, they have implied their potential applications on adaptive reuse, but they have not gone into the details of how we can use it in the process. So with that, I focused on using focus on adaptive reuse aspects, because the reuse of built assets can avoid significant portions of carbon, embodied carbon, compared to new construction projects. And majority of the existing buildings that does not have BIM models will be existing in the next 20 to 30 years. So if we can produce BIM models, it might be helpful in the life cycle of those type of projects as well. So uh, when looking into the potential, the future potential, so with an as-built model, we can and the different semantic segmentation techniques, we could try to capture as much as details as possible with Scan-to-BIM. In the last couple of months, like only 3 months, I have been doing this. So in that process, so I have worked with the Leica scanning systems. So where I scanned the Bicentennial Conservatory in Adelaide, and to create a point cloud, and like and creating the process point cloud out of it, and finally going into the Revit model. But this process was mainly manual, and it required some time and effort, and there was a significant learning curve as well with the technology. And in the bottom, you can see another technique that I identified in this literature. It's called view synthesis. Synthesis is the use of AI uh, to so how it works is you can capture a video of a certain built asset or built component. Then with the use of AI, they can try to fill in the missing gaps or the frames of this data. And with that, they can create point clouds in a better, efficient manner. So the view synthesis is currently being used in film industry and gaming industry to capture this real environment into gaming environment or virtual environment. So I'm planning to like uh, uh, like uh, look further into different models or methods available for creating these point clouds, and integrate that with deep learning techniques or different techniques that are available to create more efficient ways of creating scan to BIM workflows, so that we could produce much more efficient information models. So currently, I'm actually looking further into adaptive reuse to identify what are the potential gaps
finally happened.
Right. So currently, I'm further looking into the potential gaps in adaptive reuse and what sort of techniques and what sort of semantic segmentation methods or what sort of like LOD levels are required for this scan to BIM process. So that's kind of the future like plan for me. And So I'm currently looking into these two areas broadly with the literature. And these are the references that I used. And thank you for your attention. And I look forward to like hearing your feedback and insights about the project here.
Thank you very much, Sasanka. We've got lots of questions.
Thank you, Sasanka, and well done for persevering through the screen. I think this is really interesting and it's super relevant right now, especially around adaptive reuse. I think it would be really worth, as you look at this, zooming out and contextualizing where Scan-to-BIM fits in the design process and how it works in practice. And I think, you know, come and talk to the industry partners about that, because Scan-to-BIM is something that, you know, generally speaking, as an industry partner, we will go to a client and say, you should be doing this. But then, you know, things like costs and budget will come into play, and, you know, there might be different levels of detail are looked at. So, and then it's who owns that data, who actually owns that scan data, because it's usually the asset owner who should be owning that. So I think just as part of this, I think it's really worthwhile, because I think the technology is absolutely important in the process and streamlining that, but make sure that it fits well within the overall process. Just a point of reference.
Yeah, thank you. Thank you very much.
It's a very hot topic. Industry needs it, especially the clients, and they're struggling to find a way how to give the handover models. I just want to talk the technical side. You have two cases. Either you have a BIM model, then you executed the project, then when I hand over. So you have BIM model versus the cloud ladder, or as you said, like or historical projects. Look into technology vendors. Have you heard of Tramble? They own SketchUp.
Yeah.
I think they have advanced, because that point cloud model is not parametric model, and they have sort of a way to be it change. They lay out the BIM model versus the cloud, so you can adjust the BIM model to match the cloud. So yeah, it's a very hot topic. You mentioned the gaming. I also believe there's a technology vendor Unity. They advanced in this. Gaming industry, they advanced than BIM industry. They have lower security, cyber security, but they advanced. So yeah, it's worth checking the gaming industry. Yeah.
Thank you.
Thank you. Really enjoyed your presentation. Using the scanning technology to, I'm not sure if you've come across this, but from a waste management point of view, so in a project where you might be doing a fit out, and this is the application that I'm aware of, where they're able to, so for a client that has a repetitive materiality and forms, so the scanning is then used to very quickly assess, I mean, we don't have BIM, assess the quantity of material that is available, and it starts to provide an inventory of what kind of waste is in situ and what needs to go where. So that becomes an inventory for the contractor to then adhere to. So some of this scanning, the more accurate and efficient we can be, there's programs that then translate that into the quantum of waste that can be monitored in a contract situation. I'm happy to share with you that detail.
Thank you. Yeah, I'll be speaking to it. Okay.
Any other questions or comments? Maybe from the back.
excellent presentation, Sasanka. So not a question, but I'm just going to let you know that you were talking about automating the process of scanning.
Yeah.
I have some notes on, we have some projects we tested out, some drone swarms, and also you like little robot dogs to do the scanning. I can maybe get you in touch with someone at worked with, and they can share all this. Also, maybe look at once you've got the point out data, how are people federating the models, and how all these different stakeholders are getting the models in to deliver the as-built. So yeah, maybe catch up with me and
Yeah, sure,
try and share my notes.
All right. Thank you very much.
I need to get my stick on.
Thank you, Sasanka. You can see every time this does this, you'll hear it. I'm just wondering, your scan of the conservatory was really interesting in Adelaide because it seemed to struggle with the windows.
Yeah.
I guess my question is, what does the 3D scanning miss, or what do you potentially lose out on? And is there a way of countering that?
Yeah, so when it comes to glass facades, so the LiDAR, the scanner that I used, they struggle because like it goes through the, since it is a transparent material, so it just go through the surface. So actually, like when I spoke to the technical staff, like who's at like CR Kennedy, so what they suggested was like we have to at least like have some kind of like what do you call tape or something to like actual surface to hit the LiDAR data. Otherwise, we are unable to capture that data. So that's a small like difficulty working with such technologies. Like,
Could you combine the 3D point cloud with photogrammetry?
yeah, so like different like combining different type of sensor data might be a solution to like mitigate that effect. Yeah.
Calibration.
Yeah.
Sorry, just to follow on from that, I was just thinking also like ultrasonics, because ultrasonics don't go through solid glass walls.
So what they suggested was like combining like different other sensors with the data. So their current platform does not support like feeding different data into their original platform. So we have to like take it out, take out the point cloud. Then with Cloud Compare or some other platforms, we have to combine data from another sensor. Yeah, that's the only way they suggested. Yeah.
Interesting presentation. I just wonder, further down the track, are you trying to use this point cloud data to use some clustering algorithm to identify objects within that point cloud? Is that where you're when you're talking about point cloud to the beams, like what level of details you are trying to achieve? And
When it comes to that, like I'm mainly focusing on adaptive reuse and how like mainly focusing on adaptive, how we can use Scan-to-BIM as a supportive technology to support like certain gaps in Scan-to-BIM. So I'm currently looking into further like I'm actually currently looking into what type of problems are out there. So and when it comes to segmentation and identifying different options, like there are certain algorithms out there such as this point net, which can identify or like do the semantic segmentation of point clouds, but they have their own struggles as well. So maybe like if we are planning on a certain application, we might have to like develop or like further improve the existing techniques. Yeah.
You might be saying this, but Daniel Davis, he's done this already.
All right.
All right.
No, I wasn't gonna, but that's good. That's good. I've got lots of. We've talked about this in a. No, I had a completely different question, which was, given your QS background, you know, would it be interesting to actually look at the economics of this in a sort of global way that would be, you know, give architects some persuasive tools, you know, that to tell their clients about, you know, the value of doing this.
Yeah, currently I'm looking into like potential applications. Like it's one of the main like things in back of my head, like whether it can be applied to like cost or cost analysis or that kind of approach. Currently thinking about it. Yeah.
Hey, with your Revit model there, are those proper Revit elements or are they just direct shapes?
It's just the facade, so I didn't have that much time to build the complete element. So I just use the like outer build up like the point cloud and just try to replicate the facade only. It's just the facade.
So you're just manually tracing the point clouds?
Yeah,
or have you got...
yeah. So currently it's a manual process.
All right, we'll talk later. Maybe we can do something.
Yeah.
It's more of a suggestion. I think you need a sort of classification of a scale. Like you're talking about two different scales here, like monumental scale or scale that is quite small, and photogrammetry and 3D scanning, each has their own limitation and capability. Probably you can challenge that within the context. And then when you go even with a small component like window glass, what level of detail you can get out of the point cloud and how can you use the data, because the most challenging part is getting high quality data that depends on the use of the data. If you're talking about adaptive reuse, maybe you reverse engineer and demonstrate how it has been practiced right now and how this workflow or the new technology will enable people to improve certain part of the project. It's just a suggestion.
Yeah, thank you very much.
Yes, I'm interested in because you specify Revit as a BIM, and I'm interested in the applications that you have in mind, and because the way I kind of conceptualize the process, usually when you have a BIM model that is a model for construction, well, this is kind of the inverse. We're looking at reality and bringing that into a BIM platform. So I'm wondering how much, like, do you actually need a wall to be a wall family and a type inside Revit, or do you just actually need that data, the data you extract from the reality? I think it's great to bring that inside a BIM environment, but does it actually have to be BIM?
So I'm looking at BIM as a certain like platform to enable the interoperability. Like I'm looking into like what other possible ways like they are available to make it interoperable. So the main when we look at the literature, the main the tool that they came up with is the BIM. So that's why I'm kind of sticking into that. But I'm like ready to explore other areas. But for the time being, like this is the kind of technique that they have highlighted. So there can be other interoperability platforms out there, like format that we can use. Yeah, I'm hoping to look into those types. Yeah.
Actually, I answer you this question. It depends on how we're gonna use it. Like I'll put myself in your shoes to answer this question, the gentleman. It depends how you're gonna use the model for. Is it you want to develop the design further in? So there's a cutoff point, like you want to capture the geometry of the wall. Now, what category of the wall family and subfamily that comes in the second half? If you want to add an extension to the wall, develop more the wall, then that's the effort was going to be. So defining the geometry, I think that's the cutting point. It should be for you.
Yeah.
Like, yeah.
Thank you very much.
Any final questions, comments? No. Well, great. Thank you. Thanks for great questions.
Thank you very much.